All right, this is Honors Algebra 2 Pre-Calculus. We're doing 9.7 in Pre-Calc, which is probability. So I'm on page 678, and we're talking about independent events. So two events are independent if the occurrence of one has no effect on the occurrence of another. So here's a really easy example. I roll 2 die, right? So when I roll the 2 dice, the outcome of the first roll has no effect on the outcome of the second. The first die might be a 3, the first die might be a 5, it doesn't matter. The second one's going to roll its own roll and be its own number, it doesn't matter. So those are independent events. Sometimes it's easier to see that if instead of making them 2 die, it could also be 1 die that I roll twice, but that's not the point. Instead of making it 2 dice, maybe I make it a die and a coin, and then they clearly have no effect. I flip the coin, it's either heads or tails. I roll the die, it's 1 through 6, and it doesn't matter. So the probability of independent events, right? So if A and B are independent, then to find the probability of them both happening, so the probability of A and B, I'm just going to multiply the probability of A times the probability of B. So we're going to walk through some examples of that now. So we should be on example 7. All right, so example 7. So you flip a coin. That's not how you spell coin. And roll a die. Okay, I want to know what's the probability that you get a heads and, I don't know, let's go with 3. Heads and 3, right? Okay, so what we're going to do is we're going to do the probability of heads times the probability that you get a 3, because the coin has no impact at all on the die, and the die has no impact at all on the coin. So the probability that you get heads would be a heads out of the 2 options of heads and tails, right? And the probability you get a 3 is 1 out of the 6 options, so you're going to get that it's 1/12, right? So that's the probability of heads and a 3. Now, could you have seen that in a different way? Absolutely. The other way that you could have seen that was to write the sample space for the event out, right? We've actually written this one out a couple times. Heads and 1, heads and 2, heads and 3, heads and 4, heads and 5, heads and 6, tails and 1, tails and 2, tails and 3, tails and 4, tails and 5, and tails and 6. And you'd see that there are 12 elements in that sample space, and then only one of those 12 is both a heads and 3. So again, there's different ways to get to the same information, but it's a lot faster to understand that this is how independent events work. Let's throw in an example 8. So, example 8. All right, you flip. Let's say, we'll go with you flip 2 coins. So I'm going to ask you what's the probability that you get heads and heads, right? Both times. So that's the probability of heads on the first coin times the probability of heads on the second, because the 2 coins have no impact on each other. And you'll see that that's 1/2 times 1/2, which is a 4th. Now you can figure that out the way we did before as well, right? So if you were to write the sample space for this, you'd have heads, 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 tails, tails, heads, and tails, tails. And you can see by visual inspection that 1 out of 4 possible outcomes would give you heads and heads. So that's sort of the gist of how these independent events work.